Hello all, welcome you all to the next class on analysis of trusses by method of joints. You have already seen the method of joints numerical solved. This is the second numerical. You have briefly come across the truss, what is a truss, why is it used, where it is used, then the different conditions that are used while solving or while analyzing a truss. Analyzing a truss means basically we are going to find the type of forces that are acting in these members. We have studied there are only two types of forces, either compressive force or tensile forces. So we have to find that because of these external loadings, what kind of internal reactions are developed in these members, that is either compressive or tensile. Now, the thumb rule is I will always assume tension to be positive and compression to be negative. Coming to this particular numerical, so analyze the stress and find all the member forces. So joint A is a hinge and joint D is a roller. Okay, that is A support is a hinge and B is a roller which is inclined. Now, inclination of this roller is given as 1 by 2 slope. So from this first I'll find this angle alpha, that is the angle of inclination, which is 26.56 this. Now the reaction is going to be perpendicular to this plane, that is RD, and it makes some angle theta with the horizontal. So how to get this theta? I know that this is 90 degrees, this is 26.56, so this would be 90 minus 26.56, that is 63.4. So I have this theta to be 63.4. My first job in analysis of trusses is, based on the support conditions, I will find the support reactions. If there's a hinge and a roller, that means there are three unknown reactions. I have to find these unknown reactions first. So here is a free body diagram showing all the external. There are only external 40 and 20 kilonewton, and joint A is a hinge, so RA and HA, and joint D is a roller. This roller force is acting in second quadrant, so I'll have its resolution like this: plus y minus x. So I have shown here plus y, that is plus RD sine of 63, and minus RD cos of 63.43. First we have to find these RD, HA and RA. Now coming to the height of the truss, so I will drop a perpendicular from this point. I know that this is 60, this is 60, so the third angle also would be 60. And if one of the side is 4 meters, that means it's an equilateral triangle, so all the three sides are going to be 4 meters. So to find the height, we will drop a perpendicular from this point. So this is 90, this would be 2 meters, and this is 60. So this is 2 meters, this is the height, and this is 4. I take sine of 60 opposite upon hypotenuse, and I get the height of the uh, truss, that is 3.46. I will require this while taking moments. Now let us apply the conditions of equilibrium to the stress only for external loadings. So summation f of x is 0. I have plus HA plus 20 and minus RD cos of 63.43, which is equal to 0. RD and HA unknown, I'll name it as equation 1. Summation f of y equal to 0 plus RA minus 40 plus RD sine of 63.43 equal to 0. Again two unknowns, so we will keep it as it is. Then let us take moments at A. When I'm taking moment at A, these two are passing through A, so 0. 40 into 2 clockwise, 20 into H is clockwise, minus RD sine 63.43 into this total perpendicular distance, that is 8 meters, into 8 equal to 0. So from this only unknown is RD. I get the value of RD 20.85 positive. I'll substitute it back in summation f x and f of y to get the values of HA and RA. Remember, in analysis of trusses, whatever value you're getting, if it is with a negative sign, next going forward we will substitute it everywhere along with its negative sign. Now let us consider joint by joint in these. Pick a joint which has got the least number of unknowns. For example, look at joint B. 1, 2, 3 unknowns. Joint E, 1, 2, 3, 4 unknowns. If I look at joint A, I have only 2 unknowns. Joint D also 2 unknowns. So either A or D. I have picked joint A. Joint A show all the forces. So we have TAB, TAE, HA and RA. So I've shown TAB, TAE making an angle 60. HA and RA. HA I have shown in a positive direction, but I've got the value of HA as minus 10.67. I write it as minus only. To this now we will be always applying summation f x equal to 0 and summation f of y equal to 0 because they are the conditions of equilibrium. We have studied that for a concurrent force system the conditions of equilibrium are 2, whereas for a non-concurrent force system the conditions of equilibrium are 3. Here the forces were all non-concurrent in nature. That's why I used all the three equations. When I come to a particular joint, all are passing through this particular joint. That's why it is a concurrent force system and I use only fx and fy equal to 0. It is beneficial always if you see from practice you realize taking summation f of y is always better. You get one of the unknowns earlier. So I take first summation f of y equal to 0. I have plus RA and component of this, that is TAB sine of 60 equal to 0. From this I'll substitute the known value RA and I get the value of TAB which is negative. Then I take summation f of x is 0. TAE plus HA plus TAB cos of 60. Okay, so TAE is unknown and HA plus HA, but its value is minus 10, so I'll put it along with its sign. And TAB cos of 60, I got TAB minus, so minus 24.65 cos of 60 in the brackets equal to 0. Solve this equation, you get the value of TAE, which is the unknown. So we have found both of these forces. From there, I go to joint B. This is your joint B. So I have found this force now, only these two are unknowns, right? So I draw the free body diagram of joint B. This is unknown, this is unknown, this is known, and external loading is given to us. So to this I will apply the conditions of equilibrium, that is summation f of y equal to 0 first. So minus 40 AB component minus and TBE component with along with minus sign again. Okay, so on substituting the known values we get the value of TB, that is minus 21.53. Let us substitute in summation f of x equal to 0. TBC TBE cos of 60 positive, TAB cos of 60 that is negative. Substitute along with its sign, you get the unknown values of TBC and TBE for joint B. Then we go to joint E. So we have finished joint A, joint B. I go to joint E because these two are known now and these two are unknown. So draw the free body diagram for joint E. 1, 2 knowns, these two unknowns along with the forces and the unknown forces. Okay, so apply summation f of x equal to 0. So TEC TBE will come in summation f of y equal to 0. So TBE ಏ ಬಾಗ್ಲ ಹಾಕ್ರಲ್ಲ ನಾ ರೆಕಾರ್ಡ್ ಮಾಡತ್ತೀನಿ ಅದ್ ತೆಗೆದು ಓದ್ಲಕ್ಕೆ ಮತ್ತೆ ಮಾತಾಡ್ಕೊಂತ summation f of y equal to 0. So I have TEC sine 60 PE sine 60 equal to 0. I have the value of PE with negative sign. I substitute. This is unknown. I'll keep it as it is. I get the value of TEC as 21.53. Summation f of x, TED positive, TAE negative, TBE negative, TEC positive. So I've written the condition here. Whatever are the known values, substitute for the known values and get the unknown. That is only ED is unknown. I get the value of ED. After this, we go to joint D. That is CD is unknown and ED we have found, and RD cos of theta and RD sine of theta are here. I know the values of RD and I know the values of theta. To this, let us apply summation of y equal to 0. TCD and this component comes into picture. From here I directly get the value of TCD. If I'm doing a check, I'll apply summation fx equal to 0 and I'll keep TCD unknown. I'll not substitute and I get the same value of TCD also over here. So these on all the member forces are found by all the joints now. So you will have to put it in a tabular column showing the members and what values you have got. If you got a negative value, that is a compression member. If you got a positive value, that is a tension member. Now, if you observe, we had 7 number of members: 1, 2, 3, 4, 5, 6, and 7, and 1, 2, 3, 4, 5 joints. Okay. Now, usually to get all the reactions, one of the thumb rule is whatever is the total number of joints, minus 1 would be the number of joints you will consider. For example, we have 5 joints here, A, B, C, D, E joints. So 5 minus 1, 4. So when you observe, I have taken 4 joints, joint A, joint B, joint E, joint D. And by solving these 4 joints, I am able to find all the member forces of the 7. So whatever is the total number of joint minus 1 would be that many free body diagrams you have to put and you have to solve. Procedure is simple. Always follow one thumb rule. First find the external reactions by taking Fx, Fy and M equal to 0. Get the reactions RAHA, whether it is a hinge, whether it is a roller, including only the external forces. Next you will be applying, taking joint by joint to draw their free body diagram. Now when I'm drawing the free body diagram, I have assumed all are tensile in nature. That is why I see all arrows inward. So when I'm taking joint A, these two come. When I'm taking joint B, these two are coming. When I'm taking joint E, these two are coming. So because I've assumed all to be a tension member. Okay, this is one of the numerical. Second numerical, this is a different kind where they have not given you any support reaction. It is fixed at one end and it is free like this at the other. What we do, we have to find the member forces in this. Assuming all are tensile again, so I will mark all tension, 2 arrows inwards everywhere. And I'll start with joint A. I cannot find the reactions here because this is fixed end. I will directly start from the free end. So joint A, I have a 20, I have a TAB, I have a TAC at 30 degree. To this joint, I'll apply summation f of y equal to 0. So PAB and 20 component comes into picture. I get the value of TAB. Then apply summation of x, TAB cos and TAC. Substitute, I get the value of TAC. Once joint A is done, take B or C, any of your choice. I have taken joint C. So AC is there, C is there, AB is there, and 20 is there. Joint C, this external, this, and this. Okay. Apply summation f of y equal to 0. So these two are equal, so I get TCB 20. Apply summation f of x equal to 0. These two are equal and this is known, so other one becomes equal to that. So compression member. Then took this joint and this joint, I found all these members. Now remaining are these two, that is BD and B, for which I have to take joint B. Okay, so observe when I draw joint B, this is joint B, this is the truss and this is joint B. I need to find these two now. To find these two, I need to know this angle between them. Okay, so if this is 30, I draw a horizontal, I draw this horizontal line. So if this is 30, this is going to be 30, correct? Because these two are your alternate angles or corresponding angles. And then I know that this distance is given to us. This is how much? This distance is given to us in the question. That is AC, which is 3 meters. Okay, here it is. AC, which is going to be 3 meters. Okay, so I'll first find BC. So I'll take tan in this diagram. I'll say tan of 30, that is opposite by adjacent. BC by AC, I know the value of AC. So BC would be AC into tan 30. I get the value of BC 1.732. So this height is 1.732 now. Okay. So once I find the height, what we do next is here. Okay. I need to find this angle. If I want to find this angle, tan of theta is opposite upon adjacent. I have found BC now. Adjacent, I know it is given in the question to us that it is 3 meters. So we have found this and this. So I'll take tan inverse of BC by EC. I get the value as 29.9, approximately 30. This is 30. So now what happens? Here this angle also is 30. So when I draw this line, this angle also is 30 because they are opposite angles. And if this is 30, this is also 30 because we have seen that from the corresponding. So these two together become 60, or this is 30 and this is 30. So this is what? 60 now. Okay. So now we will see how to solve this numerical. Okay. I draw the joint B, and because this was 30, so this you have a 30 over here, and this force makes an angle 30 with the horizontal. See, it's making with the horizontal, and this is making an 30 with the horizontal. So basically all the forces are making 30 degree with the horizontal. We will solve this joint. Take summation f of y equal to 0. I have TBC 20 negative minus TBA negative sine 30, TBE negative sine 30, TBD positive sine 30. Okay, written here positive. Substitute, you'll end up to one equation. Then take summation fx equal to 0. TAB positive, TBE negative, TBD negative. Okay, this is positive, this is negative, and this is negative. Okay, now this 40 is come from this equation. So for summation f of x, I get this equation, and this is your first equation. So solving 1 and 2, we will be getting the value of the two unknowns TBE and TBD. So this is one of the different kind of numerical where one of the sides is fixed, and you will start it from the free end to solve and get the unknown reactions. In this, you have to be very careful with the angles and summation fx and summation f of y. Now here again I am mentioning that this corresponding equation coming from here, okay, and this is for summation fx. This is x and this is for y. Okay, I've just written once again to solve them, and you can directly solve these two equations in the calculator and get the values of the unknown. So that would come up with your method of joints, two numericals on method of joints. I hope things are clear. If you still have doubts, please revert back to us. Thank you.